So, 5 practical tips on making cool games quick. That's the presentation. Very shortly about me. My name is Sorin. I am a game programmer for quite some time now. And most recently, I've been working at Ubisoft Winnipeg. But maybe what's more important is that I really enjoy doing game jams and have done quite a few in the recent few years. Some of the games I made, some people liked. So my thought for this presentation was to look at what I do consistently and try to turn this into practical advice. So to not delay any further, let's just jump into it. Number 1, nail down the rules, or maybe more accurately, take your time to nail down the rules, even if that sounds counterintuitive. This one is about brainstorming, the part before you actually sit down and write the code. For us, it looks more or less like this. We have a giant mirror board, hundreds of post-its, even more comments. People are doodling all over the place. And I do like this chaotic energy, obviously, and the improvisation that also follows throughout the jump. However, we've learned to be disciplined about nailing down, I guess, 4 design rules that we try to be less flexible about changing as we go along. And those rules are the win and the lose condition, the way the player interacts with the world or how they navigate the space, and the struggle, or maybe to put it better, where the challenge comes from. And the reason for why we try to actually nail things down, even in a game jam, is because of this feeling that the games turn out much better if the creative energy is sort of applied horizontally, like towards coming up with additional mechanics, more polish, different kinds of visuals we can still add, funny text we can have in the game, rather than trying to iron out like some system that was not very well thought through, or like trying to salvage a situation where the mechanics allow the player to sort of lock themselves out of the game. So this is mostly why we do it. I don't actually have that much time to go into the bad examples, but the most recent game we made, Boombox, is like right along those pillars I mentioned. So I will just give you a quick rundown on how this would look like in practice. So the game is about defusing a bomb that is hidden inside a bunch of boxes. And yeah, your win condition is actually open all the boxes, take out the bomb, and just defuse it. Your lose condition is, well, if you run out of time, the bomb explodes. So, well, obviously you lost. The way to interact with the world is basically by swinging your mouse around. So there's a key that's floating around and it's following wherever your pointer is. And whenever you click, the key goes in towards the box in the center, and either taps on the box or like goes into a keyhole so you can open stuff. And finally, the struggle or the challenge is that each box, as you open them one by one, is some type of a puzzle. So sometimes the keyhole might run away from you. Sometimes there might be a bunch of them all at the same time, and you have to open all of them. You have to match colors, all kinds of different stuff. And because those things were pretty much solid from the get-go, we were able to figure out that many more like different ways for the keyholes to be complicated, and that many other playtest that many more combinations of like different boxes. So this is why we recommend this. It might feel counterintuitive to A, spend a lot of time figuring this out, and B, be rather inflexible about changing things. But we do really feel like having some constraints actually does boost creativity in other areas. So yeah, that's my take on ideation. Now, let's move on to tip number 2. This is, I think, where the fun stuff starts. Use a lot of movement. And by this, I don't mean it sounds obvious. Most games have some kind of movement, but actually make movement the focal point of your game. I think it's a good idea, especially in a game jam, and especially if you're a beginner or like have limited means, as far as programming goes, or like just time. Because of several reasons. Number 1 would be because like if you work in any modern engine such as Unity, as I do, you get access to a very robust physics package, which means that you can get a lot of different kinds of movement with like relatively small amount of code. right? You can have 100 rigid bodies, different properties on them, apply all kinds of forces, drag, make them slippery or bouncy, have joints to connect things together, play around with gravity. There is a ton of stuff you can do, and it really does not require a lot of system programming or like difficult stuff to actually pull it off. So this, coupled with reason number 2, which is the fact that it's just intuitively fun for humans to play around with movement and like movement-based toys. This goes even beyond games, like right, like playing with a ball, like balancing, trying to catch something or like aim at something. All of those are just intuitively things we would do for fun. So if you can combine, a powerful tech package that is like easy to use, and this simple fact, you can actually make something that is compelling and not spend too much time figuring it out. And then you can spend a lot of time actually, making it more fun, making it more polished. I do have some examples of how to leverage this. So this one is our shopkeeping game. It's about selling merchandise to people who come towards the counter. And the physical or the movement-based twist is that each piece of merchandise is actually a physical prop, which it has its properties, its weight, mass, and to get your wares, you need to pull the lever, right? And the lever always gives you more than you need. So the fun here is that because of the time constraint, because of the wonky physics, and the fact that you need to carry stacks of all kinds of differently shaped things, it very quickly gets like super chaotic and like surprising. You trip over stuff, you stress out. This is like fun through chaos, which is emergent from like natural physical properties of items. We don't have to like hand script a lot of this. This just happens because this is how physics works. So you just tweak a few parameters and get a lot of response in your game out of it. Example number 2. This one is actually about jumping and gravity, but the game itself can be a little bit much. So this is a game about a time traveling special agent. He has a stopwatch and can go back in time and essentially clone himself. In this way, he can solve puzzles around the level, collect the codes to defuse the bomb. And I could go on, but the important part is actually I think my best fondest memory from playtesting this game is the one trick you can do, which is you can clone yourself and jump on top of your past self had to just reach a higher position, and then you can do this over and over again and create this sort of weird jumping pyramid and like actually reach the ceiling or like the next level. This is really, really fun. And this is actually based on the like very tried and tested thing in video games in general, which is, jumping and gravity is just, a lot of games have done it with great success. It's just fun. If you can figure out like a crazy twist like this, I think it's a good combination. So this is why I use this example. And finally, this one is not actually a release game, but it is a very interesting kind of movement I was able to pull off. So this one is basically a rigid body that has a lot of drag, and every time the player dashes, they gain a ton of acceleration for a short moment. So this creates this very responsive, quick control over like, you can go wherever you want in the level very accurately, but also you get this gliding movement whenever you stop mashing the button, which feels really nice. I haven't turned this into a game yet, but I do have some ideas, and I really hope I can do this sooner rather than later. But the important part is that, this feels really nice. Like this is technically looks kind of complex, but actually it's just the physics engine with some lines of code in update. That's just it. Okay, tip number 3. I've talked about the movement a little bit. So now very close to it is animation. And in the context of Game Jam, I have one thing to say about it, and that is that you can probably animate it. And I really mean it. Like this is aimed at like total beginners, people who have never done this before. I think Game Jam is a very good moment to try because it's a good gateway to actually get into it, and it's really fun and not that hard to actually start. So to prove this point, here's a little shop again. This is our jump and walk cycle. And if your character is the shape of a potato, as was in our case, and as will be in many of the simple games we make in Game Jams, getting a walk cycle and like a jump is literally a handful of keys on a dope sheet. So when I say you can animate it, I don't even mean like learning Maya or Blender. You can quite simply just open Unity, open the basic animation tool, and just animate in this is the run cycle that I have on my slide. So this is animating a position of the character, and then a position of the helmet and the rotation of the helmet across literally less than 10 keys over 0.2 seconds. Anyone can do it, through trial and error. And what I actually recommend is opening YouTube and just going to the video about the principles of animation. Just watching the section on squash and stretch, trying to apply this to a sphere or a box in Unity. And I can promise you can get the basic grasp of it in one evening, and then you will want to apply this to pretty much everything you can, because it's really fun. And it does add to your game. So this is try it. It's worth it, and it doesn't take that much time. Sometimes you don't even need to animate, because the gameplay will drive the moving elements for you. So this example is very silly, but I think it's a good showcase of that. The moving parts here are the arm that holds the fishing rod and the head. And all that happens here is that the arm will follow the mouse, so you can aim, and then the head will turn towards either movement if you're moving really fast, or where you aim if you're stationary. It's very simple. It's wrong most of the time, but I think because it's funny, it just gets a pass. So I wanted to use this example to really encourage people not to be shy about it. If you have any moving pieces that can react in some way to gameplay, I would say it's worth it. You can stick this 1 or 2 liner in update. Don't worry about it being not performant. I think it adds a lot of life to your game, and it does the animation for you very naturally. So I would say a lot of the time it is worth the small amount of effort. And my final example is for situations where you don't even have that many moving pieces. So in this case, you have a box, which is one solid, and the key, which is another solid. What you can do is, those solids will still need to move around in space if it's a game, usually. So we all know the sort of infamous lerp by time delta time. You can actually have a bunch of different easings and dampening functions you can use to achieve different kinds of motions. So in this GIF, the thing that I use is called numeric springing. It was devised by someone much smarter by me, but I do have a link to their blog in my references slide, so I recommend everyone read it. But essentially what it does is whenever I need to move the box or the key to the final position, it actually overshoots a little and then goes back and overshoots again to a smaller extent, and just repeats this over and over until it's in place, which produces this nice springy, bouncing kind of movement. And also the box drives the action, and then the key positions itself relative to the box, so it all moves in this nice bouncy synchrony. I would say the effect is actually quite organic and interesting, even if the ingredients are very simple. So yeah, be mindful that you can also have this in any kinds of whenever you have any kinds of moving pieces, even if they're monolithic or simple. This works for UIs, for boxes, for any kinds of effects. Anything that needs to appear on the screen, you can spring it, you can ease it in different kinds of ways. So yeah, good thing to keep in mind. Okay, so feeling from movement in different kinds of way, animation and gameplay. Now about the juice. Some people call it the feedback, the special effects. Very quickly, I don't have cool examples, but I have a box in my background of the slide and a bunch of things inside of it. So this is what I recommend. Literally have a prefab, put your sound effects, your particle effects, your screen shake, or whatever else inside of that prefab, and then have one script govern it. And the script does literally this. Whenever I exist, I play all of my effects, and then in update, I check, are those effects done? If they are all done, I self-destruct. That's your feedback, that's your juice. This does 2 things for you. Number 1, for programmers, it creates a nice uniform way of just featuring any type of feedback in any place in code. You just expose a reference to that prefab and just instantiate it, and it does all the work for you. And for artists or designers or people who just do the effects, it creates a nice workflow where they just work within those boxes. They can duplicate them to create variants, add effects, remove effects. Whenever the programmer adds a new effect, it is supported throughout the entire game. So essentially, what this pattern does is it lowers the barrier to have effects in your game, which is a good thing to do in a game jam where you're time constrained. And this is a good way to just get that much more polish. Sometimes we do get compliments on like how much polish we get in our games, and I would say we just do this by throwing a bunch of prefabs at it. Yeah, that's my recommendation for Juice. And finally, a very obvious one, but it's super important, so I will say it anyway. Play it early and play it a ton. This is useful in a very obvious way. As most people will know, games are done iteratively. So whenever you playtest, you get that much better intuition on like what's important, what to add or tweak, or like what's good to maybe not invest so much time into. So that's all good. Something that's maybe less appreciated is if you just take the 4 rules I outlined in my slide number 1 and turn it into a game. This is like a functional game by most definition. Most like wise game design books would agree. And this is also good because in game jams or like any game making endeavor, life happens. Sometimes you have to end early. Sometimes someone has to hop out early. If you have something that you've been playtesting and it works, ticks all the boxes, you can probably finish it, you can post it online, and people will find something nice to say about it, which is very good. Finishing games is super good for learning, it's super good for motivation. So I think if you can help it, you should take advantage of this approach and always like play it a lot and like have something that's has all the basics in place sooner than later, rather than later. And if I may be allowed one last remark, you might have an intuition that you're playing your game too much, you're wasting your time, and you're playing it over and over, and getting distracted from getting all the features in. But I would say if that happens, this is good, because this probably means you've done something cool, which in the end, this is what it's all about. Thank you.